This video is sponsored by Noragon, the commercial vehicle data experts. Visit noragon.com to learn more.
Jeez, all the time. I don't know. I mean, I'm all for being green and sustainable, but these motion lights, I don't know if this is really helping.
I mean, yeah, they're great in theory, but I don't know. I feel like I'm wasting a lot of time jumping around trying to keep these on. But if I did things correctly, I think I figured out how to override the system.
Oh, what's the solution?
Well, what used to be duct tape over the light switch, it's now all up to coding and programming with these LED lights. So I have to do it all on here. But if I did it correctly, we should be able to keep the lights on between 9 to 5, Monday through Friday.
Excellent. No more arm waving.
No more arm waving, not if I can help it. Okay, 3, 2, 1.
Was that supposed to happen?
No.
Hey everyone, welcome to FE's Data Center, the series that aims to make truck data approachable. I'm Jason.
I'm Tess. Sustainability initiatives across trucking brings us closer to an electric truck reality, and some are already working hard in short route applications. But with electric truck operations comes service troubleshooting. Now, technicians are faced with new and at times unexpected challenges during the servicing and repair process.
That's right. Diagnosing and repairing a traditional truck can be like unraveling a classic whodunit, utilizing familiar clues and techniques to solve the mystery. However, working on an electric truck adds a technologically advanced dimension to the puzzle with intricate wiring diagrams, obscured components, and a multitude of computers and sensors that must be analyzed to uncover the answers that you seek.
But don't let that scare you from solving the issue, because just like any good detective, technicians have all the tools and all the knowledge needed to crack the case wide open and get these trucks back on the road. You don't have to wait for an electric truck to enter your fleet to start electric system training.
That's right. Some of the biggest pain points for technicians is troubleshooting electrical systems, including diagnosing and identifying all the issues, even on a diesel truck and electrical systems. Techs need to understand complex wiring diagrams and schematics and find and access relevant components within the system. So let's brush up on electrical system service tips.
Before all else, be sure to completely clean batteries and battery boxes. Remove and clean all cable ends and replace all bad ends. Load test each battery on the lead portion of studs or install lead cones. Replace batteries that do not hold a 9.5 volt load, approximately 300 amps for 15 seconds with a maximum loss of 3 volts. And check for chafed cables and hold downs. If that doesn't solve the problem, it might be something else. So what are the biggest pain points for technicians troubleshooting electrical systems? How might this evolve as electric trucks come to the market? Well, apparently I am not the tech whiz to ask, so...
That's right. Let's turn to our friends at Noragon for their thoughts.
A few of the biggest pain points that techs can face when troubleshooting electrical systems or components are ease of access to the system or the component and its wiring, access to troubleshooting documentation or technical specifications, and the tooling necessary to perform the job. There's many learned tips and tricks that seasoned technicians will use to narrow down the scope of a problem, given the resources they have available to them. Once the problem's been narrowed down from a general area to a specific area, this is where pain points can typically arise. You might have figured out that the problem is in a bundle of wiring here or in the dashboard, buried down over there. And it's times like these that can take more time just to gain visibility to the area of problem than actually furthering the diagnosis. Troubleshooting documentation and technical specs are key to successful diagnosis because they can, one, tell you how to remove and install things if it's not obvious to do so, and two, they can also describe in detail how something is supposed to work and what it's supposed to do when it's working correctly. Couple this with the correct diagnostic tooling and training is what allows you to actually confirm or deny whether something is working as designed or if there's a problem. I feel that diagnosing electrical issues, as technicians have traditionally done so, will change when it comes to electric vehicles, both in ways that make it easier but also possibly harder. Access to troubleshooting materials and technical specs will be even more important here, not only to know how something is supposed to work, but from a safety perspective. Working on an EV requires you to be diligent about the components and which ones actually tie into something high voltage. And knowing this beforehand can be the difference of life and death. And approach of diagnosis will likely change some of the mindset, since many components on EVs are built as remote smart devices that have enhanced onboard diagnostics. We already have a lot of that going on in diesel-powered equipment today, but many EV architectures are entirely built on this concept. Component sensors and circuits that used to be external and accessible to technicians are now internal to a device, meaning there aren't many things that a technician can actually do to physically repair them, other than simply replacing the component if there's a problem.
With a healthy mix of technician training, education on the intricacies of electrical systems, and support from providers like Noregon, the EVs that roll into your bays can be serviced safely and correctly. You'll have them back on the road in no time.
Thanks for watching.